In this video, I will be using Micro 810 PLC to control three conveyors, normal operation, start, stop, and in the same time, I will be using the user-defined function blocks to help me with programming those three conveyors. You can see, depends what version you have, you might see user-defined function, or you can see add-on instructions instead. Both are the same here. I'm gonna be using these to help me control the conveyors. In my case, in my example, I will have three conveyors and each one of them controls separately, but conveyor 2 will not run until conveyor 3 start running, and then conveyor 1 will not run until conveyor 2 start running. So 1 and 2 depending on 3, 1 and depending on 2, 2 depending on 3, and that's why we don't want the box to keep going all the way through and get to 2 and stops because the conveyor is not running. So we want to make sure the conveyors are running. So here we have three conveyors. We're gonna control them the same way, so to make our logic easier and smaller, that's why we're using user-defined or add-on instructions. Let's start here. I'm gonna create a. I'm gonna start from scratch, so I'm gonna create a new project. I'm gonna call it UD create. My PLC is the 12AWA. Here you go. So first, if you're not familiar at all with the user-defined function block, you have to know what do you want, how you're gonna control your conveyors. So like you want to press start for it start. Do you want before it starts? Do you want to check to make sure the safety circuit is good? Do you want to make sure? In my case here, I want to make sure the conveyor next to the current conveyor that needs to be on first. So we need to know all this, and then you will know what tags you need to put inside this user-defined function. So I'm gonna create the routine for this, which is I'm gonna use ladder logic here. Here you go, created empty subroutine, and here also it gives me a place where I can put the tags that I'm gonna be using inside this function block. So here again, I'm gonna be writing all the programs that control all the conveyors in the same way. Like it's gonna control one conveyor, but I'm gonna use it again for the second conveyor and use it again for the third conveyor without have to write it more than once. I'm gonna write it once, and then I'm gonna point to it every time I need to control another conveyor the same way. So what we need, so first we need to start putting tags to be able to fill our logic. So let's go open the local variable for this user-defined block, and we start putting tags. So here again, you can already know what tags you need, or you can start putting them down, and while you're going with the logic, you can start add on later. So for example, I'm gonna here always every user-defined block I create an enable bit for this block. So I'm gonna start with enable n for an input, and it's gonna be like I said input. So I'm gonna have to change the direction as an input. And if you're still a little bit confused with what I'm doing, you will understand when I finish it. You will understand what I'm doing here. So second, I want to input that tells me to start the conveyor. And here I'm not saying conveyor 1, conveyor 2, because this logic will be used for all the conveyors I'm using. Doesn't matter 3, 4, 5, how many conveyor I'm using. And so I'm not gonna be assigning any conveyor number to this logic yet. You will see why if you're still confused. And also I need stop. I want to stop the conveyor. I want to input to tell me to stop it. Also here I'm gonna be using a feedback from each conveyor. So like feedback, signal, and let me not forget to assign all these as an input. Variable means this one is not gonna receive or send any data outside the block. This tag, if I keep it variable, this tag it will be used inside this block and is not gonna communicate with outside the block. But when I say variable input or variable output, that means the input is interacting with the inputs outside the block, and the output is communicating with the outputs outside the block. But so I need all these to be inputs, and that's why I assigned n before it. And also another thing, we need to make sure the safety is good. So in stop, and it is input. And also, like we said, we need to make sure the next conveyor is good. So in next, let's go next conveyor is an input. And in case, in some situation, you want to look to the previous conveyor, let's add it. In my example, I will not be using it, but I will show you like how, if you have a block already set up and there is a tag that you don't need, but you don't want to delete it. So, or for example, you want to create user-defined general to work in every situation, and then you bypass whatever you want to. So let's add it, and I show you how we can deal with it since we're not monitoring the previous conversion. And then also here we will need the output now. I think that's enough for input. The outputs we need out. Tell me if the conveyor running. And here you go. I'm gonna assign output. The command for the start actually. Out start. Let's call it CMD the command. And its output. And the last output is if the conveyor get let's call it out false. This false, you will see now where I'm going to use it, but if the conveyor got the command to start but it didn't start, I need a signal to tell me it's faulted. Okay, so I have these tags, and if I miss something I can come back and edit it. That's fine. So now I can go to my routine and I can start doing my logic how I want to control each conveyor. So first, if I want to make sure if I press start, so now I go here and I find my start. If I press start, at the same time I have no the e-stop circuit is good, and maybe I want to monitor the next conveyor. I want to make sure the next conveyor is good. And like we said, if we want to monitor the previous conveyor also, and at the same time, the stop button is not pressed. I want you to turn on, to give a signal out signal to start the conveyor. If all this true, all of them good, and this is not pressed, so turn on. Give me an output signal to tell me to turn the conveyor on. And then add a wrong, and here I'm gonna say if I received a feedback from the conveyor that is running, I want you to tell me that it is running. Good. So that's that's by itself it controlling the conveyor. We need to stop it if you want to stop it, but let's do this before that, the faults. If I give it a signal to start and still I'm not getting a feedback that it started, I need to know that the motor is not starting, so I want to give a false signal, for example. So here, let's say the output command is on, but the feedback is not on yet. Give me false. Just a signal to trigger a message in HMI or whatever. But at the same time, I know that the motor sometimes doesn't start right away, or it doesn't get on speed, in a high speed right away. So depends on your feedback system. If it's encoder, you might be able to see it right away turning, but changing positions. But if it's a proxy, for example, that monitoring as a full rotation of the motor, this proxy, it might not see the motor is running until the motor goes in full cycle, full rotation. So that way, the motor maybe needs few seconds, whatever. It needs time before it shows you the feedback. So in this case, what we're gonna do is add a timer to wait. After I give it start signal, I wanna wait a few seconds before and then monitor the feedback before I give any faults. Let's do this. Let's add a timer. We go here to timer. What we need a delay before for on, time on delay. There you go. And here we put how long we want to wait. T bound. I'm gonna say 5 seconds. So it's gonna give it the signal command, signal to start. It's gonna count 5 seconds. If the feedback comes to us and before these 5 seconds elapse, then everything will be good. If not, the false signal will turn on. And here the last thing is if we want to turn off the motor with pressing stop, for example. So let's go back here, highlight it here. If I press stop, or also the e-stop circuit is not satisfying anymore. So I don't see the e-stop input anymore. Or if the next conveyor needs to be on and it's the signal gone away, is not on anymore, I want to stop my conveyor. Or same thing, if I'm monitoring the previous conveyor and the previous conveyor turned off, I want my current conveyor to turn off. So anything if this happen, I want my conveyor to turn off. The output signal, the output start command, turn it off. And here you go. So going back to the local variable, I want to show you the timer. It's variable now. It's not an output, it's not an input. I'm not getting any signal in and out to this block to control the timer. This is internally in this block. It's just gonna count 5 seconds and that's it. So, okay. Here's my full program that I'm gonna be using to control any conveyor in my application. Doesn't matter how many conveyors. So I want to control conveyor 1. I'm just gonna call this logic, let it go through, and then it's gonna give me some outputs. It's gonna tell me if I should start my conveyor. If it's gonna tell me if my conveyor running. It's gonna tell me if there is a fault, or it's gonna tell me to shut down my conveyor if I need to. Depends what coming to this block is gonna give me an output. So let me show you how to call this logic every time you want. We go to programs now. We create a new program. I'm gonna use ladder logic again. Program. Here where I'm gonna call it. So if I didn't create this user-defined block, I will not have this option, user-defined. But now, because since I have a block under my user-defined, now it shows me, oh, you have this option, and it shows me the FB1, which is the one I created. Whatever you name it here, it shows it here. So FB1. So if I click it once, it's gonna bring it here. Here's my function block. You see what everything I assign it as an input variable. It put it on my left side as an input. Let me bring my mouse here to show you as an input, and everything I assign it as an output, it brings it to the right side for an output. And here the tags I'm gonna be assigning in, and these the tags I'm gonna be reading from the like input is gonna be writing to the block, and the output is gonna be reading from the block to do whatever it's supposed to happen. So uh, so so now I'm gonna uh, say here conveyor one. So this is for conveyor one, and we're gonna say conveyor two. And we're gonna bring one more FP here for conveyor 2, and we're gonna have another one for conveyor 3. And as many conveyor you add, and let's bring one more FP. Okay, so here we go. We have 1, 2, 3 for our 3 conveyors. And instead of have to write all the logic, and now instead of having to write all this logic for each conveyor, I wrote it once, and I'm just in my main program. In my main program, I just call it right here, just 3 line, one for each conveyor. Instead, all this logic, I'm gonna close these so I don't keep opening them. Instead of all this logic for each conveyor. Okay, so now we're gonna fill those tags. What these tags are mostly, most of them is going to be the physical input and output. So start is going to be the physical push button, start push button. When I press it, it's going to bring input signal to the start tag in this block, and then in this block, the start tag will turn on, and if everything else is okay, the output will turn on too. So I will have an output for the start command. So let's start accumulate these tags, and now we need to create those tags. So if it's a physical input, you just bring the physical input tag here. In my case, I'm not gonna use real physical inputs and outputs. I'm gonna just create the tags and use those tags so I can be able to toggle them on and off in my convenience. Okay, so under the local variable, until if these are gonna be physical input and output, so they have to be global variable. So the physical input and output is gonna be a global variable. So let me create my tags inside my global variables. So what the tags that we need to control our conveyors. So like we said, we need the conveyor one start push button. I have a start push button for conveyor 1, and it's Boolean. And also I have a start push button for conveyor 2, unless you want to use one button for all of them, but normally each conveyor will have its own start button. Here you go. And the same thing for stop. For conveyor 1, for conveyor 2, and for conveyor 3. And also the feedback from conveyor 1, from conveyor 2, from conveyor 3, and after that I need to know if it's I need to the signal for running. Conveyor 1 running. I want it to tell me if it's running. Conveyor 1, let me copy that. Conveyor 2, conveyor 3. We need the output start signal that is going to be going to the drives, the motor, whatever, how you start the motor, the starter. So you're going to have to give it a signal, the output signal to start. So conveyor 1 start command. Conveyor 2, conveyor 3. We said also if we have a faults, we need to know. So conveyor 1, let's say start fault, call it like that, or fault start. Conveyor 2, conveyor 3. And for our safety, conveyor 3. And for our safety, we have the e-stop signal. That's going to be common for all the 3 conveyors. So these are the signals that going to be coming in and out, like physical input, physical outputs, some tags that will be used in main programs. So now in our main program, let's call it main, rename it main. So in our main program here, for starts, I'm gonna use the conveyor 1 starts, push button. For stop, I'm gonna use conveyor 1 stop, push button. For the feedback, conveyor 1 feedback. Here, the e-stop now. E-stop signal. The next conveyor. This one is for the next conveyor, and the other one is for this one for a previous conveyor. For the next conveyor, here this is conveyor 1. Am I monitoring the next conveyor? Yes. I don't want conveyor 1 to run unless conveyor 2 is running. So I just said it. Conveyor 2 is running, so I need to monitor conveyor 2 running signal. Okay, am I monitoring anything previous to this conveyor? No. If there is door closed, whatever signal you want to monitor before you start this previously to this conveyor, that's okay. But I'm not monitoring anything. If there is another conveyor behind it and I want to make sure this conveyor is running before conveyor 1 is running, I can use that. But in my case, I'm not monitoring anything for this previous signal. So I want it to be on and never turn off. To do that, I need to add, like, for example, an always on signal. I need to create a tag that's always on, and I can use it here that will never turn off, so this signal will never bother me. So let's add tag for always on and always off. I created a new rung, and I'm gonna just put a coil, and I'm gonna call it always on. Let's copy that. Let's define this tag, and I'm gonna add it inside the local variable here for main, because I'm gonna use it only in the main. So here we go, always on Boolean. That's it. Okay. So this tag, when the PLC starts, always will turn on. It's always gonna be on, never gonna turn off unless the PLC off, which is that doesn't like if the PLC off, nothing gonna be working. So this always on. Let's copy it and let's use it for here. So now this input will always be on. So now when I press start button and I'm not pressing stop, and the feedback still is not coming yet, the e-stop is good, the next conveyor is running, the start button is pushed, the e-stop is good, the safety good, the next conveyor is running, the previous I know it's on now because I have it always on, and I'm not pushing the stop, so my conveyor should start right away. And when this starts, I should be receiving this signal. Conveyor 1 start command. It should turn on, and this should go to the physical output that turn on a drive or motor. And the faults, if I have any fault, yep, it gives me false start. Running now, which is in the first signal here, running, when this turn on, I want it to give me a conveyor 1 is running. So here you go. And just to let you pay attention to this, the way you organize them inside here, the tags, the way you organize them here, they will show here. So here I put output running before other output, like for the output ones here, I have running is the first, and then start command second, and then fault third. That's why I showed that running is the first, start command is second, and fault is the third. And the same case for the inputs. The way you organize the inputs, the same way they're gonna show up in the block. Let's say, for example, you by mistake, you didn't have the enable here, and that's why I told you about enable. I don't want enable, you want this block to stay on all the time. So when this routine is running, you want the voltage or the signal to go to this block and it stays on it all the time. You don't want to control it with this. You want to control it with these tags, inputs and outputs. You want to control the block by pushing the start and stop and stuff. You don't want to control this enable. You can add a tag here for example, if there is a conveyor that sometimes you use it and sometimes you don't. You like your specific your application allowed you to add a conveyor or take it off from the process. You can add here a tag right here where I'm gonna use, for example, the always on tag, but you can use a special tag or whatever where you can disable this block so that signal will never go air. So whatever buttons change, whatever this happen here, it doesn't affect your outputs at all anymore. So you disable it. So this is it's gonna be like a life bit to activate and deactivate this block. That's why I use enable instead of start or stop, because I want it to stay on all the time, even if I press start or stop or the feedback to turn on or off. I want this block to be on all the time. Let's say you want to edit. Let me show you this. Let me show you something here. You made a mistake, and you want to change this tag. You want to add another tag in the top of this. Like for example, I forget to add the enable. I start from starts and now I noticed too late. I noticed that, oh, my start bit starts in the top, and I want to move it down. What I'm gonna do? So the way I do it, I go to device. I open the local variable for the tags I want to edit. Then we go to device, export variable. We save it in our desktop anywhere you want, and it's gonna open it for you. And these are the tags that you created already. So now we're gonna fix it or edit it or add more tags. So like, let's fix this. Let's add a tag, test, and it's gonna be boolean, and it's gonna be input. There you go. So let's save it, close it, and when we come back here in the same location, let's import it. All right, it imported it for us. And now as we see it, like here's the tag we added and the tag we fixed. It left this probably because we already used it many times in our main program. So now in my case, if that happened, all you have to do is just delete this one. And here you go, it shifted everything down. Now we go back to the main and we have to update this because this still has the old configuration, enable, start, stop. So we're gonna have update this one, which is double click on it. Make sure you highlight the FB one, which is the same block that we updated in, and press OK. Here you go. Test, enable, start, all of that shifted. It added test and new tag and shifted everything. And you're gonna do it for all of them if you need to. So in my case, I don't need that really. So I'm gonna go back to my tags, delete this one that I added, and here's the way I wanted it. So I go back to my main, I updated it again, and here you go, enable, start, stop. And that's how you edit, update, add tags, whatever you want. So now let's keep going and let's fill all these. So if we want to put the same tag in the beginning here, and we need to output for the running, so let's fill it up. So here, convert to now, convert to starts, convert to stop, stop, the feedback, convert to feedback. The e-stop is the same signal for all of them. The next convert, we are monitoring convert 3 now. The running signal for convert 3, that's what we are monitoring. Previous convert, if we need this convert to run only if number 1 is running, then we put convert 1. But in our case, no. In our case, we're not monitoring anything previously, so we just make it always on. This signal will always be on, nothing will affect it. And then for the outputs, this is convert to running signal, and this is convert to start command and the faults. Default start. No, this is for 3. I need 2. Okay. Oh, this is convert 1. It needs to be convert 2. Okay. All of it 2, just this one 3 and 2. Good. So here the same thing. Convert 3. Start. Push button. Convert 3 stop push button. Convert 3 feedback. The e-stop. The next convert, are we monitoring anything for this one before the start? No, so always on. This signal will always be on. Unless there's a machine, you need it to be on before the conveyor starts and you put the machine running. But in our case, no. And also we're not monitoring anything previously, so always on. The output, let's start from here. Let's add the running, convert 3 running signal. That will be controlling convert 2 and 1. Convert 3 start command, and conveyor 3 false. 4, yeah. So this, like I said, conveyor 3 running is the signal that I use as interlock for conveyor 2 running, for to start conveyor 2. And conveyor 2 running is the interlock other than the e-stop and other stuff. It's one of the interlocks to start the command for conveyor 1. So this is my logic. I think it's good, and it's ready to download. Let's download it. So download. So now it's gonna be downloading. Yes. Okay, good. All right. So it's still downloading. Okay, it's finished downloading now. There you go. Okay, now we are online. So here conveyor 1. Let's look into the instruction inside the block. Here it shows me that the stop is okay, the previous is okay, and that's because we have it always on the previous. So it's on. So now it's waiting on the next conveyor to be running. The stops signal, the e-stop safety signal is good, and the start push button pressed. So first, let's turn on the e-stop. Toggle it. Now I have the e-stop, and it's the same signal for the 3 of them. So all of them on. And let's go back here. So now the e-stop good. The next conveyor. So number 1 is waiting on number 2 to start, and number 2 is waiting on number 3 to start. So let's go to number 3. Let's see what number 3 is waiting on. Number 3 right now is good. The only thing is waiting on is the start push button. So going to the main, let's push the start push button. Start push button is pressed. The command is on now. Let's go back here. The command is on. Here you go. Oh, we saw the timer counting. Well, we'll come back. So the everything is on. The command is on. So now that's why here the command will be true. But the running is not true because the feedback is not coming. Even I gave it a start command, the motor didn't tell me it's running. So the output running is not on yet. So let's go back and turn the running on. Here you go. Feedback, toggle it on. Now the conveyor sees the PLC sees the feedback in from the motor that is running. So turn the running on. Good. So now I have the command is on and the running is on. No faults because everything is running. If I have the output here is running, but the feedback is not coming, I will see the faults. So for example, now I have the command is running, right? Let's turn off the feedback, like as we're not getting a feedback. Now we will start see the timer counting for 5 seconds, and then the fault will come up. There you go. It's on right now because the command is on and the feedback is not coming. So the fault turn on. There you go. Fault is on. But when the feedback comes back in, the fault goes away and the running turn on. Good. What if I want to stop it? The stop push button. So when I press stop push button, the command will turn off. From here we see if I push stop button, it's gonna open this circuit, so nothing is gonna go here, and it's gonna turn off it's gonna reset the output signal. So let's see. Let's toggle the stop button. Here you go, turn it off. Now the running is gonna stay running until the feedback turn off. So if in most application, in a normal application, you will have a brake on the motor. So when you stop the motor, you set the brake in the same time so it stops. But in my case, there's no break, and it's imaginary input and output feedback. So let's say the motor is slowing down now, and when it stops completely, I will lose the feedback signal, and when it turn off, the running conveyor will turn off. Good. So let's turn it on again. Turn on, and now I see my feedback on. Oh, okay, my feedback on. So the motor's it's running and everything is good here. I go back to number two. Number two, now it was waiting on number three. Number three is good. E-stop's good. So that means it's only needs the start button. Here it goes. Only need the start button. Okay. So let's turn on number two. And now I see the feedback, for example. So everything is on now. Number two is running and good. Number one. Number one was waiting on number two, because number two is running now. E-stop is good. That means all it needs is the start. So push starts. There you go. The command turn on. And now the feedback is going to come to not allow the fault to come, and running is on. Okay, good. That now I have my three conveyors running. Let's say, for example, number three stops. Number three, the command, let's say you push the stop button, the command should turn off. So let's, so the command will turn off. So let's turn off the command. So the command is off, but it's still running because it's still slowing down. So the feedback, I still see feedback. So that's why I still say it's still running though. So when I lose the feedback and it says stop now, here we go, number three stops. Number two, the command stopped, but it's still running because it's still slowing down. And that's why I'm seeing the feedback, but the command turned off by itself. So now when I don't see the motors running anymore, you will see this one, and if I turn off the feedback, the running will turn off, and this will turn off right away too. So let's turn off the feedback. So the motor now slowed down completely and turn off. So now it turn off here, it turned off this. So this turn off, number one turn off the command. So now it's slowing down until it completely die. And here we go, conveyor turn off. So that's the case here. And the same thing with if we turn them on again and do the e-stop, for example. Let's turn all the conveyors again. I have a feedback. It's on. So number one, now I need to push the start button. It's momentary, so that's why I just pulse it. Turn it on and off right away because it just pulse it needs. And here you go, all of them on. Now I'm gonna e-stop circuit. Somebody press the e-stop. All the start commands should turn off. But one by one depends on the running signal again. But you will see all the start command turning off, but the running signal, it will be one by one, depends on the feedback signal. But let's turn off the e-stop and look at the start command. So e-stop turn off, e-stop turn off. There you go. The command for 3 turn off, the command for 2 turn off, and the command for 1 turn off. So now the 3 motors are slowing down until the feedback goes away. You will see them all turning off. No more running. And here we go. And that's it. That's the using the user define or add-on instruction in PLC 810, and it helps a lot to keep my logic, as you see, just like 3-4 rungs instead of 4 for each conveyor. Instead of 12 rungs for the 3 conveyors, it's just like 4 for all of them and 1 for each. Okay, that's it. If you have any question, please let me know. Comment it down and I will answer. And thank you very much.